Hi guys, it is Monday, week 2 of homeschooling by video and Google Classroom. I just want to let you know of a couple of the changes. First of all, the governor and the superintendent of education here in Arizona have announced that we are going to be homeschooling now at least until April 10th. This is not unexpected. It was one of the things that they were talking about earlier. We know that in some states, schools have closed until the end of the school year. We're geared up. Last week we all got ready. We practiced. We're good with this again. I'm going to really encourage you to set a routine for yourself so that you get up, you have a special time that you are sitting someplace, devoting time to your schoolwork. You're not falling behind, and according to the research that's being done, depending upon how fast you work, how many breaks you take, the average homeschooling student should be spending between 3 and 5 hours a day on their schoolwork. Again, if you sit down and you're dedicated and you plow through it, you do your work, you should be fine. Today we are mostly videoing, so you're going to have mostly videotaped instruction and a discussion question that will be posted in Google Classroom. I am going to put some worksheets up that will go with the work that we'll be doing tomorrow. There are a few additional vocabulary words today. They are in your document that I've attached to Classroom, and I have highlighted in yellow all of the information that should be placed inside your notebooks. On Friday when I went in, I brought our cart down from the classroom. It is in the hallway outside the library. So if you do not have your science notebook, please go in, pick it up, and be able to continue on and use the notes that you have. All right, so let's get to it. So today we're going to talk about the Grand Canyon. I told you last week that we have on our doorstep here in Arizona a geological record of the North American continent for the last 1.7 billion years. Those layers were formed before the canyon was formed, and we're going to talk about the fact that the canyon was the Colorado River, forged this time, and we're going to talk about the oldest and the youngest rock layers that are in the canyon. The first vocabulary word that I want you to be aware of is the word stratigraphy, and it is the study of rock layering. And that rock layering reveals a lot of information to us about how each of those layers were formed, what was going on in the environment at the time, how long of a period of time that those circumstances continued, as well as a wealth of other information. Within the Grand Canyon, there are very clear horizontal layers of rock. You can see them. They're very easily demarcated, some thicker than the other. And then, of course, the law of superposition, which we also talked about on Friday, talks about how these sedimentary layers go down in a sequence. The oldest rocks are on the bottom, the youngest are on the top. The principle is a key part of determining the relative age of each rock layer. The three main rock layer sets in the Grand Canyon are grouped based on position and common composition. The first is metamorphic basement rocks. The second is the Precambrian Grand Canyon supergroup. And finally, we've got the Paleozoic strata, strata meaning layer. These three main sets of rock were first described by the explorer John Wesley Powell during his expeditions of the Grand Canyon in the late 1960s and the early 1970s. In your document, there is a link to the usgs.gov website that has some information on Powell's expeditions. It is really fascinating reading. These were extremely harsh circumstances. It's not like rafting down the Grand Canyon today. It was a really challenging and dangerous time to be exploring the Grand Canyon, and lives were lost. So that would be an extremely interesting thing for you to take some time to take a look at. Also embedded in that document, your first diagram shows the Grand Canyon's three rock sets. So take a moment to familiarize yourself with that. And it shows the stratigraphic columns, it shows the rock layers, and it distinguishes between those three sets of rocks. The other new vocabulary word we have today is unconformities, and unconformities are gaps in the geological record that occur when rocks and sediment are eroded away, so we see a time elapse before new deposition occurs. New sediment will eventually form new rock layers on top of the eroded surface, but there is a period of time, there is a period of geological time that is now no longer represented. So you might think of these as missing pages in the geological time book. Now, they're not really a problem because even missing information can lead us to new discoveries and new information. And it's a way for geologists to find out about changing ocean levels or changes in the Earth's crust. In the Grand Canyon, these unconformities are common, and they are the Grand Canyon supergroup, and they're also visible within the Paleozoic strata. There are 3 types of rock visible in the Grand Canyon, igneous, sedimentary, and metamorphic. We know that the igneous rocks were cooled, melted rock found underneath. These are intrusive igneous rock. This is exposed internal igneous rock, and it's been exposed by erosion. And we also have sedimentary rock that's being formed by smaller pieces of rock and mud and siltstone and chert and limestone and more. The sedimentary rock is the rock layers, the rock layers that contain fossils, index fossils, and we've heard that term many times this year, going all the way back to talking about Alfred Wegener. They are particularly abundant in a relatively narrow time layer. Over time, pressure increases, sediment increases, and minerals help form these rock layers. The metamorphic rocks are formed when sedimentary or igneous rocks change due to the exposure of the heat and pressure. We went through that last week. And again, we can find all 3 of these types of rocks within the Grand Canyon. The metamorphic basement rocks are the oldest rocks in the Grand Canyon. They are found at the very bottom of the Grand Canyon. They're primarily metamorphic rock with igneous intrusions. The igneous intrusions are called I always have trouble pronouncing this word, Zoroaster granite. That's the name of the rock that has the combination of metamorphic and igneous rock, and they're found at a certain age. And these are called the Vishnu basement rocks. They're primarily schist, which is metamorphic, and the granite, which is igneous. And these rocks have very visible crystals, and we know with dating that these rocks are 1.7 billion years old. So that is the bottom layer that we see within the Grand Canyon. On Powell's expedition, when he went to explore the Grand Canyon, he called the area of the Grand Canyon where the Vishnu basement rocks are the Granite Gorge. And it must have been an extremely imposing site. You can go on virtual field trips down the Grand Canyon. One of the videos that I put for you on Discovery Education, you'll see this. And with the Vishnu basement rocks, you're going down and the canyon narrows, and you just have this really, really steep sides that we have to the Grand Canyon. The reason that the canyon narrows is because of how hard these rocks are. Sedimentary rock forms in a very different way to metamorphic rock. Therefore, it's harder for the Colorado River to actually erode through the Grand Canyon. And these rocks are very important because these rocks actually tell us the story of how North America formed. And North America formed when volcanic islands collided with continental landmass and forming metamorphic rock through that intense heat and pressure. Volcanism continued after the collision, and as a result, we have the igneous intrusions that occurred after that metamorphosis. And remember, the only way that metamorphosis can change or that metamorphosis can end is if that rock actually goes back down through the crust and melts once again. And I have put in a picture for you of some of that Vishnu basaltic layer. The second picture that you're going to see has a white line drawn through it, and that is part of the Grand Canyon supergroup. You can see that it moves up and down. Those layers change in terms of the depth of them. And the Grand Canyon supergroup is that middle rock set that we see in the Grand Canyon. It's primarily sandstone, mudstone, and there is some area of igneous rock, but primarily it's sedimentary rock. And we can date these rocks back to the Proterozoic era. They're only slightly younger than those metamorphic basement rocks. These rocks don't contain any fossils. We're still way too early in terms of the formation of complex life on Earth. But there are a few fossils that are present, and these fossils are stromatolites, which are columns of sediment formed by cyanobacteria. And again, we're going to go back to the time when we talked about cyanobacteria and the very importance of its presence in the early formation of our Earth because of the production of oxygen with the first plants that are able to perform photosynthesis. So the composition of sandstone that's present shows a lot of stromatolites that are in that area, and that indicates that at that point in time, that area was being covered by warm, shallow seas. The rock layer of that supergroup was also tilted, so some of those rock sets are horizontal. This is known as an angular unconformity, and it's called actually in the Grand Canyon, those things that have been eroded away, the Great Unconformity. Not very original. Obviously, geologists aren't that creative in their naming protocols. We then get to the Paleozoic strata. These layers are sedimentary. They're primarily sandstone. And this makes up the vast majority of those reddish layers that we often see in the Grand Canyon. And I want you to think back to Friday's lesson when we talked about the different types of materials that have to interact with the water that's being squeezed out of the pores during that compaction period. And so you can see at various times that there are different elements that are affecting it. The more reddish ones, we know we've got iron oxidation occurring. So, but that is where the vast majority of that Paleozoic strata is the vast majority of what we actually see and think about when we think about the Grand Canyon. So following the Great Unconformity, we've got all of these rock layers that are formed, and this is where we see most of the fossils that are prevalent. The most common fossils are small sea creatures such as brachiopods, bryozoans, we've got corals and crinoids, combined with the sandstone, once again, talks to us about warm, shallow seas where these sediments are deposited. I also want to point out where we've got a long period, a long presence of these crustaceans, these brachiopods and trilobites. When they died, they leave behind the calcium of their shells. As this breaks down, this is part of what helps form limestone. Okay, and we're going to talk about more about limestone tomorrow. And we can't have limestone without those calcium deposits. And we can't have those calcium deposits without those organisms living. This is not a period of time where we've got land animals. We've only got sea life. Therefore, we know for certain that we had warm, shallow seas covering those pieces of land during that time. That's really important, and I cannot stress that enough. That's really important to remember. Limestone, there has to have been the presence of sea life. So we've got all of these old rocks, but essentially our canyon is not that old. It is surprisingly young. So when we think about the Grand Canyon, one of the things we think about is the canyon itself. The width and the depth of it are truly remarkable. The exposed rock layers are, again, there are not very many places on Earth where we can actually see so much of the Earth's history exposed in this manner. After all the rocks were deposited, we also had a period of uplift. That is a bolded word in your document, and that is also a new vocabulary word. You need to remember what uplift is. And this is where plate tectonics literally force a section of the Earth upward. All right, so rather than those layers, we're going to get an upward piece, which you can see at several points of the Grand Canyon. And this sets the stage for canyon formation. It provided a high enough elevation that water can now flow downward, cutting through the rock as it goes. And of course, this is where we have the early formation of the Colorado River. So that uplift is required for creating that slope so that water can now flow down. And with that flowing down, we get the formation of a river. And over time, it is that river that carves the Grand Canyon. I want you to think about the Grand Canyon and all those amazing pictures that we have. At some points, the canyon is so wide, and then it'll narrow, and then it'll widen again. And at some points, it's extremely narrow and extremely deep. There are parts of the canyon that you can walk down to in a day. And we have sea level at the bottom of Phantom Ranch when you're going down the Bright Angel Trail. But at the top, it's vast, okay? So that means that there were times in history where the river was wide and flat, and then there were other times in history where the river was fast moving and narrow. And the canyon has been carved over millions of years. The canyon itself has formed more recent deposition of the rock layers. This is only about 5 million years ago. Believe it or not, again, it's exposed 1.7 billion years worth of rock layers, but the canyon itself is probably about 5 million years old. Our oldest layers, well, it's probably a bit older, but the vast majority of it, of pushing down through the sandstones, about 500 million years old. And the youngest layers that are exposed are really only about 300 million years old. It takes a long time for a rock layer to form and compact and cement. That weathering, erosion, deposition, compaction, cementation process takes a very long period of time. It doesn't happen quickly. But what we have seen, though, is the canyon forming at varying rates, with period of intense erosion carving the canyon, and then periods where there has to have been quick movement, where it carved deep but not wide. I think it's the third diagram that we see, where I want you to look at, where you can see the Colorado River forming, and that's flowing through the bottom. And again, we've got those enormously wide gaps at the top. You can see some narrowing as the canyon bends, and then you can see it narrowing still as you go down through the picture. And you can see that the canyon at the bottom is not really that wide, and that picture shows the confluence of the Colorado and the Little Colorado rivers. All right, the river continues to be an agent of change. It's continuing to shape the canyon over time. The canyon is not fully formed as long as water is flowing. So as long as the Colorado River is flowing through the canyon is going to continue to develop. There is currently ongoing research in terms of how erosion and deposition takes place. It hasn't been, in the age of the Earth, it hasn't been going on for that long of a time, really. What we consider the top of the Grand Canyon is the Glen Canyon Dam. That would be point 0 in terms of the Grand Canyon. And we've recently dammed up. By recently, I mean in the early 1960s. By damming up the Colorado River at the Glen Canyon Dam, we have changed how the Colorado River moves. And as a result, we're able to watch the changes that takes place as we release water through the canyon. I also want to talk a little bit more about the fossils that we find in the Grand Canyon. And again, this is really important. I mentioned on Friday how you can find trilobites on top of the Himalayan mountains. That can only mean that at one point that was seafloor. Okay, so and we've had the movement of plate tectonics pushing upward, so that those mountains, the Himalayan mountains, have formed over time. Within the Paleozoic strata, we have several fossils that help us learn about the geological history of North America. Most of the fossils are of ocean-dwelling creatures, telling us that the area that is now the Grand Canyon was once the middle of Arizona was once a sea. And some of the most common fossils that we find in the Grand Canyon are trilobites. You can find loads of trilobites and ammonites. Trilobites were invertebrates that lived in shallow marine environments. They varied in size. You can find them very small, and you can also find them extremely large. At geological shows in the past, I've seen trilobites that were up to 1 foot wide. They were huge. They were index fossils for the Paleozoic era, but they were also prominent during the Ordovician era. And if you don't remember what those are, refer back to your notes from the beginning of the school year and the history of time chronology that we created there. We also find trilobites a lot in Bright Angel Shale. It's not at all unusual to find a trilobites fossil near or around the Bright Angel section of the canyon. We also see a lot of trace fossils. Fish are a common thing that we find as a trace fossil, where we don't actually find the fish itself in the fossil, in the sandstone. What we find is the impression of where the fish was. We find a lot of organisms such as trilobites and worms that are trace fossils, and it's usually found in what was once muddy ocean sediment. The burrows, again, we don't find the worms. The worms had no physical structure. What we find are the burrows of the worms. So the burrows have the shapes of the worms, and it can be kind of cool to take a look at that. We also have brachiopods. There is in the document I gave you, there is an example of a trilobite. There's an example of the burrows left from worms, and there's also an example of a brachiopod shell that has been preserved in limestone. Brachiopod shells are also quite common. They were during the same time period and are common within those Paleozoic rocks. Okay, so that is the end of what we're going to talk about today. Again, I want you to go back, stratigraphy, unconformities, and uplift are important vocabulary that you need to know for today. Make sure today that you watch the 2 Discovery Education videos on the Grand Canyon. Tomorrow, there is a discussion question that has been posted with regard to the lecture for today and those 2 videos. It's not a very complicated one. I basically want you to be thinking about what the Grand Canyon does for us in terms of being able to provide the age and the history of the formation of North America. I know that Miss BT and also Mrs. Peichel have more work for you today. Your parents' email kind of gives an outline of what we're expecting for the week. I really, really hope you're doing well. Stay safe, stay well, and I will talk to you tomorrow. My office hours have been posted in the video to your parents. I will be holding office hours at 10 o'clock every Tuesday and Thursday morning. Talk to you later. Bye.